Hello and welcome to this first webinar of 2026 from A2EP, looking at new tools for modelling renewable heat solutions. My name is Jarrod and the CEO of A2EP. So yes, we've got a few presentations here today to run through a series of new tools that have been developed over the last 6 to 12 months, and one that's coming a little bit of an oldie that we produced a couple of years ago, and we'll dust off that as well. And so this is going to be running through three tools and one website with an extra expert to kick it home for us today. So the tools we're running through: Renewable Heat Selector, which is a generic tool. We'll do that first. Heat battery estimator, looking at things maybe known as thermal energy storage or ETES, and the developers of those from Aratherm helped with the Canberra Innovation Network. And we'll quickly touch on the heat pump estimator tool, which is a few years old now, but just reminding people what's available there and round that off. And to remind people also well, we have this Future Heat website, which is a fabulous resource with case studies and what have you. And so joining me today to work through that, we have Llew Reilly, is the systems manager, developer rather, from Aratherm. Brendan Voss, Energy Tech Partners, the director there, and Peter Rykenberg is the director at Process Partners. We're going to kick off, first of all, with Brendan and I going through the renewable heat selector, handing over to Llew to talk through the heat battery, and then back to Brendan and I for the heat pump, and then kicking it home with Peter telling us how to do real modeling and detailed modeling. So that's the plan for today. So the renewable heat selector, it is been developed over the last 6 months or so with consultation with OEMs and end users, and we're ready to do something of a launch here today, and we'll be able to open that up and invite people to use that. The tool is meant to complement and fast track people on their decarbonisation journey. Certainly not intended to replace good quality advice. And that's exactly why we have a presentation from Peter Rykenberg to show if you want to do this in a detailed manner and thorough, Peter will show us how to do that. But a few key tips about the tool and how to use it. This is trying to guide on methodology. The right methodology is the best way to make decarbonisation economical. And a few of our tips. Don't do like for like. If you just do like for like, we'll call that, say, lazy electrification or a lazy job. And it's very often not going to be economical. Invest in data. I'll say you a $20,000 or so investment in the right metering solutions could easily save you $200,000 or $300,000 from your renewable heat solution. Consider hybrid solutions, and we'll hopefully get a look at that today when we use the tool. But if you use your existing gas system to maybe handle some peaks and troughs and use the heat pump or electrification or other solution to do the most of it, we think you'll get a far more economical solution. Another big lever is monetizing non-energy benefits, and that could be allowing you to increase production or some sort of other safety or reducing water consumption. And so when you monetize those non-energy benefits, that really moves the economic case a lot as well. But we absolutely acknowledge every site is different, and it's very hard to come up with a full, nice, generic, easy, one size fits all. So for sure, get an expert consultant on board sooner rather than later. I'm going to skip this step for the moment, but do show you all the introduction screen, and it's a reminder of those tips that I just provided you there. There's acknowledgement in terms of use and privacy policy in there, and I think we'll be adding in the assumptions for this shortly. But this, once you've logged in, you'll very quickly come to this screen, and it is designed so that you can get an answer, some ideas on your decarbonisation journey within 1 minute. But of course, we're encouraging you to take 5 or 10 minutes or more to put more data in. And so it is set up, and let's give us that 5, 10 minutes now, and we'll go through how that is. And it's set up so that you can select any sort of different area there, and by selecting your different sector or your facility type, you get more customized results. So we're going to go with an aged care facility here, and go for something. Yeah, Victoria looks good, and you can save that as you go. How much does an aged care facility spend on gas, Brendan? 50,000 a year?
Cool. Yeah.
Sounds
something.
about right. I don't know too many people at $12.15 per gigajoule now, more likely in $25 if you include all the network costs. So yeah, let's say they're using 2000 gigajoules. That looks about right. Um, I think an aged care probably have a similar ratio, maybe a little bit more for electricity, but let's say $60,000 there. And we'll say that's most of probably a blended cost of 25 cents a kilowatt hour. We save that one. What technologies should we look at? I'm just going to focus on a few of the electrification ones today, and so I might take out the geothermal and flat plate. But this is where you can customize what you want us to give you advice on. Certain technologies that you think are going to be relevant. Sometimes these won't always come up because maybe your demand is not above 150 degrees. But this is a way of sort of fast tracking the design, and away we go. And that the final step is some financial pieces in there. You can apply a carbon tax if you want that to come into the model as well, but we'll leave that blank for the moment. And you cross your fingers there, Brendan. There
Yep.
it is. So, is that the baseline state? The baseline will costs will come up there. Typically not in this one at the moment. There we go. But this will show you the costs there that you can expect with using a low temperature heat pump and combined with a gas boiler. If you do just a low temperature heat pump, we're suggesting that's going to have a slightly higher amount because it's got to be sized a bit larger for those peaks and troughs. And so straight away we say, well, there it is. And there's the baseline there. We're saying $95 a megawatt hour is for the baseline if you're just using your fossil fuel gas. So straight away you say, well, this is the sort of ballpark that you're fitting in a little bit over the baseline at the moment for that rate that I put in. Maybe if you got some better, more solar power or better solar rate or something like that, that would change straight away. And I think we can actually change that. I'll try that on the fly. Maybe you've got some solar and that would then come into maybe a blended rate of zero point 0.5. And let's see if that one then comes up and hopefully gives an alternative there. Oh, didn't update there, Brendan. Come on, tell me why. Usually that would happen
Because
about.
you wouldn't update the here there's still like you're still pretty early on here um in the model. Like if I'm in the next step it'll update, I'm not so sure that that blended rate influences that as much as it should right
Let's have a
now.
look. So there you go. You can
Next
find
phase
out the
it'll
solution fairly quickly, but then we're suggesting then, hey, go in for some more detail. And so after that, it's continue to the next section and fill out a series of more answers there. And so this is an aged care facility. So let's say it's got 100 beds. It's very typical for an aged care. Of course, aged care is open pretty much 24/7. So it's 52 weeks, 7 days, and 24 hours. However, how often does it need the heating? And so that maybe, let's say we said we're in Victoria, so that might need the heating for some 30 odd weeks a year, 7 days a week, but maybe the heating system is really only required for sort of 16 hours a day. And that gives you that estimated operating hours and that impacts that capital intensity there. And the primary heating, let's say this is mainly for air conditioning there. Right. Now we can work out a little bit of costs. If you've got existing boilers and you need to write them off, that's going to a big impact. So we'll say it's 10 years old, the existing boiler right now, and probably going to be somewhere around about sort of 400 kilowatts or something, maybe a little bit smaller, but that'll do that. You can enter more number of boilers in there and say whether it's standby or not, but we've only got one, so clearly that's not going to be the standby boiler. We'll save that. We move on to if you've got a flexible network provider, maybe that means you can get a very low and good tariff, solar soaker tariff, like the likes of Essential Energy does. And Lou Riley will take us through that on the heat battery estimator as well. But let's say, for instance, we don't have that a flexible connection. We've just got low voltage. Um, Typical aged care facility, Brendan, bit of space, not much space. What do you think?
I think there's normally a little bit, not an oval worth, but there's normally a little bit down the side even.
Yeah, not like a hemmed in office tower or something like that. And so that means they'll probably be able to have some easy access for that one, no big craneage. Probably got hot water going through around the building already. And we won't say anything. We'll just leave this for blank for the moment for other use on site. Solar PV capacity, probably something there with maybe 100 kilowatt or something system on the rooftop there. And the utilization of that usually doesn't get too high, but let's say 60%. And what portion of the site is renewable? We might say that's 100 because it's got a PPA to go with it. What percentage of your electricity generated on site? I'm going to put that as 50. And does it have spare electrical capacity if we're going to electrify? You say yes, it does. And I said a 400 kilowatt heat pump, COP of 4, maybe you need 100 kVA to get that installed. We'll say we won't look at biomass for the moment or anaerobic digestions. That's more for a food plant. Save that one. And here comes the next review of that. And all of a sudden, with some new factors, we're saying, wow, that's really coming down. Brendan, as expected there, you think?
Yeah, well, once we get into a bit more detail on the model, we can start to modify the amount we think it's going to cost on a capex number. And we also, in this next step, run a more detailed efficiency model on, say, the heat pump itself. So anything that might be influenced by an ambient temperature or something, we
Yep.
get into a bit more detail. Yeah.
Good one. And so next step, we're looking at sort of a bit of a data quality on the site. Yeah, this is just an aged care facility. I'd say that the heat and mass balance is not too complicated, so I might say yes on that one. Can you map the demand? It's not going to be too hard. We know we use this much hot water and this much space heating, so say yes. Have you had a metering implementation plan done? Most haven't. Have you had an audit done? Most, I'd suggest most haven't. And so that means you've probably got an option to improve your energy demand there. So that's a little bit on that. Incentives. I'm going to leave this blank for the moment and we'll see what happens there. Let's say that incentives for that one we think is going to be zero from Eskies, Veeks or Accus. Obviously, Accus not for a small aged care facility, but Eskies in New South Wales and Veeks in Victoria, yes. And we don't think we're going to get any grants for this one at the moment. Can we get accelerated depreciation? Not at the moment. Let's hope for the feds come out with that in the new budget. Would a new heating solution allow you to increase production? Yeah, well, maybe it means it'll help me bring on a few extra beds or something like that, just for argument's sake. A new heating solution reduce water. It's going to be an air to water, an air a heat pump, so no. Would it help you get a better electricity tariff with that higher consumption? I'll say no for the moment. And does the new solution reduce site labour needs? I'd suggest a gas boiler and a heat pump. Probably not. Probably not too much different there. Any other benefits from from this, Brendan? Anything else you think we get from installing this heat pump at a aged care facility?
For the sake of keeping it simple here, no, I could probably think of a few that we could spend time on, but yeah, maybe just say no for now.
Will do. And I'll bring up just let people know that if you say I'm not sure, I'm not sure, I'm not sure, you will be prompted to say, okay, here's somebody who can help you there. But you're right, we'll say no for that one. And saving that, and I think there's about the last stage. Can the technology participate in grid services? Certainly not for something that small. Can byproducts be monetized? That's more going to be an industrial thing. And does the new heating solution use a waste stream? Probably not for aged care. And there it is. Well, certainly coming out better and better. No doubt when you start considering the opportunity to increase production, you say, well, okay, this business case starts looking much, much better than a baseline for the fossil gas. So, uh, look, that's the majority of that right now. There's some other factors we could play with, but I think we move on. Um, are we ready to press AI there, Brendan? Do you think that's all the info that we need? Would you get an AI result here?
Yeah, that's it. It's now run all and stamped the data and given that into an English version of the technical data to the AI engine. So let's see what it comes up with.
Oh, should have pressed that a bit earlier. But yeah, this we are using Gemini for this one, and it's the paid model, so hopefully it gives a bit of quality. Certainly, the results we've looked at the past from this, it's been fairly impressive, and some really good extra tips that come through, customized for what your conditions and things are. Yeah,
I think we
sure
should
is.
also preface, Jared, that some of these values might there is an update to do on costs for equipment, site costs, and everything. So they will get updated progressively, and the more
Yep.
data we get from market, the better this will get, and the more accurate
Yeah.
it also.
And look at that. So here we go. Put their gigajoules in there as well. $30 a gigajoule with 80% boiler efficiency. You've got a 10-year-old boiler, mid to late life. Here's your electricity price in there. Um, let's see if I scroll. I'm fighting it at the moment as it scrolls down. This is saying a low temperature heat pump is a recommended one, with one with 2 hours thermal storage, highly recommended. And we'd see that as it optimizes your electricity tariffs as well. And they've got space to do that. Marginal benefit for the gas boiler. Might be a bit more consistent loads for this versus an aquatic centre than Brendan that we've allowed for at the moment. Um, Low feasibility, probably the extra you're going to end up paying for the biomethane might may make it electrification looking better. A few critical things to consider. Production benefit was good. Current boiler is 400 kilowatts. Size different because of run longer periods, intensities. Yeah, guide you towards not doing a like for like system. This is an interesting one. I like this one. Victorian incentives. You said nothing from Eskies or Veeks. I would urge you to urge a second look. The VU program specifically incentivizes this. So that's a nice little tip, and we expect that's the sort of thing you get from the AI and that customized view. And then finally, yep, 100 kilowatt, the most financially robust electrification via low temperature heat pumps and thermal storage. Brendan, you reckon that's something close to what you'd recommend?
Yeah, well, it's pretty much what the model will actually recommend anyway. And I did find this output very close to what the model does recommend, even though actually the this summary is not linked to the model output itself. It's actually linked to the calculations along the way, and we're
Yep,
not actually tying necessarily our end levelized cost of heating up directly to this even yet, and we're still getting very similar.
good
So
one.
it's quite a powerful engine.
Nice little
I do
tip
like
forward
the
here.
rhetorical question as well. Are we
Yeah,
subsidizing the grid while we evaporate our own margins? Possibly.
this is it.
Possibly. Yeah.
I like a little tip at the end here, get that metering and implementation. So track the COP. So if your supplier says, I'm going to give you a COP of 3, okay, well, let's get the metering in there to prove that and the annual energy savings. And so I'll open this up a little bit now and for questions. If there's anything there, please put that in the chat or the Q&A box, which I can't say. Maybe just pop that in the chat. This is the other one that is possible afterwards. So if you want to get a series of quotations, you might say, oh, give me a quote now, put me in contact with a heat pump supplier. I need someone to look at my electrical design, energy procurement, metering hardware, and maybe a little bit extra solar PV. Put your name in there, email address, mobile number, and boom. Right now, these are all going to me for the moment. Where this is the final piece of the puzzle, one of the few that we're putting together. So this will then send all that data there. Go to a couple of suppliers and say, hey, would you like to help so and so with this one? That's one piece. The other piece, and I mentioned a little bit before, if you're saying I don't know, hey, connect with an expert. Again, this will send you off to and match you with a energy consultant or some sort of consultant that's in your area, likely to help you out. And so we're populating this at the moment, and we'll put that out there. If someone wants to make sure that their details are in there, and please do get in contact with A2EP. We'll have you included there. Uh, Brendan, what did I miss?
No, nothing other than just the preface that I had of some of that data needing to be updated. Some of the numbers probably don't look exactly right for the moment, but the structure of the tool, yeah, is well defined. So I have nothing to add.
Thank you. And so please, there it is. It's renewableheatselector.com. Get out there and use it and feel free to give us some feedback. Quick question there, Brennan. Is there a CapEx estimate provided as part of the tool? I know it's sitting there in the background.
It is, and when you look at the graph that comes out, the tool itself, it'll actually color code or heat map those by capex intensity
Mm,
versus opex intensity. So it'll by looking at that on the side, you'll be able to tell immediately what the most capex heavy thing is, and it'll give you a dollars per megawatt hour view. Um, it doesn't give you a specific dollar number, but all of that lives in the back. So I mean, this is all the feedback we need to see exactly what data you'd like.
Good one. Thank you. Question there from Ruth. A statement for our auditors about the impartiality of value for money of the range of suppliers this tool would reach out to. Um, we can certainly do that. We've got a list of suppliers that we know of out there, certainly like in the likes of energy consultants, and we keep track of which areas and things they're working on. And yeah, we'd certainly be able to provide something to that, to say impartiality. We have and people in that there's A2EP members and there's A2E non-members in there as well to show that there's that non-bias, impartial information as well. And the calculator again, there we go. Thanks, Tom. It's the renewableheatselector.com. So give it a shout. Let us know if some issues with it. Any requests for improvements, let us know. We're planning on still doing some improvements on this over the next few months. So there we go. Good one. Well, that's the renewable heat selector tool, and that gives you a whole range of technologies. One of the very exciting technologies that a lot of industrials are looking at right now in Australia is thermal batteries, sometimes referred to as thermal energy storage systems, sometimes referred to as ETES, but certainly an emerging, very good solution for decarbonising industrial sites. And so we worked with Aratherm, supported Aratherm, and it was Llew Reilly, the brains behind the tool of this one. So Llew, I'll get you to share your screen and take it away, and let's have a look at the heat battery estimator.
Thank you very much, Jared. I'm assuming you can see my screen.
Gotcha.
Awesome. My name is Llew, and today I'll be presenting the heat battery estimator. As Jared mentioned, we developed this in partnership with A2EP and with assistance from the ACT government under the Energy Innovation Fund. So I'd like to start with an acknowledgement of country and an acknowledgement of the people that lived in Australia before colonisation. Today I'm presenting on Gadigal land in the Eora Nation. You can see here in New South Wales. A little bit about me. So I work for a company called Aratherm. We provide advisory and development services to industrial heat clients with a focus on renewable heat solutions. So I do most of the sort of programming and some of the financial modeling for Aratherm. So the motivation, what is a heat battery? So here we can see in the dotted line, the dotted black line, the wholesale price of electricity. And this is sort of a typical day. You can see that in the middle of the day, right when there's lots of solar in the grid, this really drops down very, very low, and often it actually becomes negative. And so we can take advantage of that, of these very low wholesale electricity prices with a heat battery. So a heat battery works by taking energy from the grid or behind the meter solar and it stores it as heat in the heat battery. So a heat battery typically looks like a bunch of sort of hot rocks in an insulated container. So it stores this electricity as heat in these rocks, and then you can draw that heat out as you need it for steam. You can get quite hot temperatures all the way up to sort of 1,000 degrees or more. So as you need it for the factory. So the motivation for the heat battery estimator. So most industry to supply heat, they use gas, and gas as a source of heat is pretty well understood. It sort of ranges from about $12 a gigajoule to greater than $30 a gigajoule, depending on what type of gas you're using, how much gas you're buying, and where you're buying it from. But that's pretty well understood. So we sort of wanted to do a similar thing, but for electric heat. Note in this tool, we haven't tried to include capex. We're just looking at the cost of energy. So there are many contributing factors to this cost of energy. So the sort of main one, I guess, is the electricity itself. So here we've used the 5-minute wholesale price from the NEM, from AMO, and this varies by region in Eastern Australia. And there are also some admin costs associated with buying that electricity as well. The second main one is the network costs, arguably the biggest one. So this depends on your network tariff, and this cost goes towards paying for sort of the poles and wire and all that grid infrastructure. And the third class of the contributing factor is the green scheme charges. So these are charges or sort of tariffs imposed by the government to pay for different green schemes. Some of them are federal to pay for large and small scale renewables, and some of them are state specific. So we take all this data from the last financial year, and we put it into the Aratherm dispatcher. So this does optimization and simulation of this data. So I think there's about, and we do this for every single scenario. I think there's about 2,000 scenarios in the heat battery estimator. And then we put this into the heat battery estimator and show it in a nice GUI. So we're going to jump into a demo of the heat battery estimator. When you launch the heat battery estimator, you'll be open, a tutorial will be open for you. And you can see here sort of a visual of what the heat battery estimator sort of looks like. Oh, sorry, what the Aratherm dispatcher sort of does. So you can see here we have natural gas, we have LPG, goes into some kind of pipe, goes into a gas boiler and produces heat for the factory. And then we've got this electric heat system sort of alongside that. So the idea is we're running these systems in hybrid. So it comes from the grid through a wholesale meter, either through to an e-boiler or an e-TES, or a heat battery here, is what we're calling it. And then this goes into the factory as well. So the first thing in the tool is you select some of your inputs. So in this case, I'm in New South Wales. So I'm going to select New South Wales. We're going to select a heat load profile that's food and beverage. I'm going to keep the gas price how it is at $16 a gigajoule for now. And I'm going to keep the network tariff at this essential energy tariff for now as well. So the first thing I'll do is I'll explain sort of this main graph that we have in the heat battery estimator. So the x-axis here is the percentage of gas displacement. So here we're assuming that the status quo is that you use 100% gas to supply the heat for your factory. And we're looking at the percentage of that that is displaced when you bring in this new electric solution, whether that's an e-boiler or a heat battery. And the y-axis is the cost of heat delivered in dollars per gigajoule or dollars per megawatt hour if you prefer that as a unit. And note that this doesn't include, again, this doesn't include any capex, and this doesn't include other operational costs like warranty costs, for example. So you can see here that we have our 100% gas case here at sort of 0% gas displacement, and at an effective cost at $20 a gigajoule. So this is on the output of the gas boiler, but before any steam reticulation losses. And similarly, we have an example point. This is one that has, this is a particular heat battery which is displacing 14% and at a cost of $8 per gigajoule. But we'll jump to the next graph for a few more points. So you can see here, here we have a heat battery that has 8 hours of storage. And you can see here that the general trend is if you want to displace more gas, then it's going to cost you more money. And the reason is that we're using the wholesale price of electricity. And so if you just buy the really cheap wholesale prices, then you can get pretty economical gas displacements. Or in other words, in this case, you're displacing 40% of your gas at a cost of $8 per gigajoule. But as you try and displace more and more gas, it gets more and more expensive. So to see here, in this particular case, to get to 100%, it's going to cost you $24 gigajoule per gigajoule, which is above the cost that you'll be paying for gas. So the second general trend that we see in heat battery estimator is that adding more thermal storage helps. So in this case, you can see the thermal storage is represented by the size of the marker. You can see by this legend over here. So this is an e-boiler here, and towards the right hand of the chart, we have a heat battery with 16 hours of storage. So you can see here that the e-boiler is displacing 14% of the gas at $8 a gigajoule, and the heat battery is displacing 54% of the gas still at $8 per gigajoule. So much more displacement when you add thermal storage. The last thing to explain is this cost breakdown graph on the right-hand side. So when you click any of the points, you can see that. So if I just leave this tutorial to show you that. So here is the full tool and this graph on the side. So you can see here in this particular case for 100% displacement, we have the wholesale electricity in blue at $36 per megawatt hour, and then the network tariffs at $28 per megawatt hour. We have the retail premium here in red, and then these three here are the green scheme charges that I talked about before. Cool. So the first thing, one of the most interesting things that you can do with this tool is that you can compare different network tariffs. And to do that, I'm going to go to Victoria, where actually PowerCore has just introduced a new tariff. So before we get to that, um, let's talk about the tariff that we currently have selected. So this is an AusNet sort of standard tariff. It's representative of sort of the standard network tariff that you get. And you can see here that network tariff costs are sort of pretty significant at about $50 per megawatt hour, or about $60 per megawatt hour. But the new Power Core tariff is massively cheaper. You can see there. So this red line, remember, is the cost of gas, and so this Power Core tariff, this new one, which is for a flexible load, really gets much cheaper. So you can see here, even at 100% gas displacement, we're still below the cost of gas on an energy cost basis, of course. Um, but yeah, like if you only want 69% gas displacement, then it's only going to cost you $6 per gigajoule. So can definitely helps the economics. Another interesting thing about this tool is that behind every one of these dots, as I mentioned before, is a separate simulation and optimization. And so we can sort of view that by looking at this show time series button. And so here you can see sort of a bit of the data behind the tool. So you can see here that this is the last financial year. And if we zoom in, we can see more a bit of what's going on. For example, let's have a look at this week here. So you can see here we've got about sort of 5 days. This line in red in the middle graph is the heat load profile. So this is our food and beverage heat load profile that we've got built into the tool. And the green here is the electric heat. So this is the heat load that we're supplying with electric-based heat. And the little bit of yellow that we have is from gas heat. In the bottom graph, we have the heat battery state of charge. And you can see here that we charge in the middle of the day when there's lots of low prices in the grids. That's what this blue line is basically the wholesale price plus all the other little bits added on. So we charge then, and you can see that we discharge at other times, and in this case, we don't quite have enough thermal storage to sort of get through the night, and so we actually have to use a bit of gas. That's what this view shows you. And the last thing that I'd like to show you in the tool, there's lots of things that you can view on this tool, but is actually visualizing the network tariffs. So this is an example of an essential energy tariff in New South Wales. And there's three types of network tariffs. So network tariff charges. The first one and the simplest one is the fixed charge. So in this case, it's $25 per day. So pretty insignificant in the scheme of things, for this particular tariff at least. The next one is an energy rate or a volume rate, sometimes it's called. This is in dollars per megawatt hour, so dollars per unit of electricity used. And you can see this has different time of use bands. We're looking at a week. This is the x-axis here is a week of data. So that's an energy rate. And the last one, which is arguably the most complicated, is a demand rate. So this also has different time of use bands noted by the different colors. And it's in dollars per kVA, which is unit of power per month. So this is really looking at the peak amount of power that you use in each time of use band. And actually, our dispatcher optimizes for all three of these, but in particular, we'll look at if you just optimize the last one and the difference that makes, because this is sort of the most complicated one. So I will switch back to the slides. So here in pink, you can see a non-optimized version of an example tariff, AusNet tariff. And you can see this is the non-optimized version, and in the green is the optimized version. So you can see that by doing that demand charge optimization, it's about a 40% decrease in the cost of heat, with an even bigger decrease in the cost of those demand charges. And with that, I will conclude my presentation. If you're interested in decarbonizing your heat processes, then come talk to us at Aratherm. I'll hand back to you, Jarrod.
Yeah, thank you so much there. And I think we can see how you've got the renewable heat selecting tool. You can only do so much when you want to consider all these different techs and give you an idea. Then you drill down and we take it further and say when you do this heat battery estimator, okay, we can start modeling with some different items and things there. And so then we'll show with Peter Rykenberg's presentation, when it's time to really do it for a site, you've got to go to another level of detail again. But that's great. I'll just check if there's any questions there for you, Lou. If not, maybe you can hit those in the chat if any questions do come up. Let's see, it looks like heat battery doesn't allow for modeling the actual time of use tariffs for a business retail contract. It only uses a wholesale price. Is that right? It just uses wholesale price at the moment?
That's right. It does just use a wholesale price. So the retail tariffs that we've looked at aren't very economic. They've always sitting like far above what you get where you get for with a wholesale price. So that's the reason that we've chosen there. It's possible that there are retail tariffs that do exist in very niche circumstances that might be better, but we haven't seen any yet.
Good one. Thanks, Lou. Thanks for your question there, Trent. And from Mark, yes, this recording will go out, so we'll be able to you'll be able to use that one. We'll have this posted on YouTube. Lou, how do you handle seasonal wholesale pricing? If I'd used a crystal ball for a while, it looks like summer wholesale electric prices are going to be largely secured and fine with plenty of solar PV. What are we doing in the middle of winter in a Dunkelflauten, no dark and no wind? Can the tool handle that sort of situation?
Yeah, great question. So we're modeling this on the previous financial year, which of course is a full 12 months, so full summer, full winter. And during those some periods of time, in that particular financial year, there was this kind of situation where the wholesale prices were high for, a period of a few weeks. And so in that situation, what the tool does is it generally prioritizes burning a significant amount of gas in most circumstances. Because you always then is in a situation where you have a hybrid solution, you've always got that gas boiler to fall back on.
Good one. Thank you so much. Okay, and if there's some questions, pop in the chat and Lou will get to those as well. Brendan, I thought we'd round out all the tools there, and I'm hoping you can just do a super quick, a couple of minute version of the heat pump estimator tool, and just to say this is that package of three tools. Are you able to share your screen, just run us through a quick example?
Here. This heat pump estimator lets us go a little bit more detailed into actually sizing the heat pump really. So what I'll show you is just the brief inputs. We have to tell the tool where we are, what's our facility type. Now we pre-built quite a few of these, and I think in the future could probably just let you input a load profile on your own. But you can move and modify this load profile and move the peaks to different hours and stuff like that. So there is already some reasonably cool features here. It'll let you change when the plant operates, when we need to actually deliver heating. It'll ask you questions like, well, what's our average heat required? What's our actual peak heating capacity? So just because we have 1 megawatt of average heat or 1.5 megawatts of peak heat doesn't mean we need to deliver 1.5 all the time. So if we see the average at about 1 and 1.5, how many hours do we need the peak for? Let's say 2. And I took some nice temperatures of 60, 50 for a hot water loop and say that's pretty good for a heat pump. And we just click the next button. It's going to ask similar questions on fuel costs, dollars per gigajoule, dollars per kilowatt for your electricity. I did some, like if I change this number here to, I've got really good solar and I've got a nice blended cost of 12 cents a kilowatt hour and my gas is $15 a gigajoule. You can just change these to whatever you like. If you know your annual heating cost, we can just back calculate that from here. It'll then ask you for a heat pump type. We have quite a few. I just chose propane because that seems to be the winner on air source, particularly for an aquatic center. And then what we're asking here is, well, for thermal energy storage, how much do you want to actually let that, how small do you want to let the heat pump go and how much do you want to rely on the storage? The lower you put the mechanical heating portion of the heat delivered, the bigger the thermal storage gets. If you then say, well, I actually need an extra 30 minutes of flexibility in case that peak extends for 30 minutes, you can also just type 30 minutes here. I could type 60, I could type 180, it'll just add water and modify the heat pump size. And the result is we get a pretty good look at, it recommends we put 1,076 kilowatts of heat pump in, which is on the average, just on basically. It recommends we have some storage to cover all of that. It gives me some CapEx numbers, which were at the time, although this is a little bit old now, Jarrod, was very well researched. Got a lot of supplier information from that. Importantly, it gives me what my power input is going to be, what my demand impacts might be, and how long it should be, just at very, very high level, concept level, till I could see that money back. Now, obviously, extra monetary benefits, like we said before, like we might get more efficient as a building. We might be able to change site, do other things downstream that save money. So that just continuously improves from here. And we also have a white certificate calculator here, which will be inspiration for what you might see and then what might happen if you were to go and claim those over that period of time. So this one does have, like I said, a very detailed video online already that walks through what every one of those inputs are and how to run multiple scenarios. So yeah, that should be a pretty good overview.
Thanks, Brendan. I thought it was just good to round it off for all those tools and see what's available. And so that leads into our final presentation. So we've given you a summary of what's available with those three tools. The renewable heat selection tool gives you a very broad look at a lot of different technologies. Llew took us through the heat battery estimator, and that's got some nice modeling there of different tariffs and size of the thermal storage. And then we've got the heat pump estimator tool. These are just designed to get you started. And we have to acknowledge that every site is different. Unbelievably, like that, just no matter what, there's always going to be nuance to each site. And there's definitely this, what we're doing here cannot model every scenario. And so I thought, let's take a look at a bit of methodology of how you do this for an actual live site. And so I've asked Peter Rykenberg, the director of Process Partners, to come along. Have done the first electrified dairy manufacturing site in Australia, and so have got a lot of lessons have learned of how to do that and how to do this modelling. Peter, over to you. Love to hear how the expertise from Process Partners comes through to do this actually on the ground.
So I don't claim to be a heat pump specialist, but we look at the food manufacturing sector in particular is where we work, and we're looking at how we can drive the opportunities to deploy heat pumps and other technologies around decarbonisation in food manufacturing. And really what I'm going to talk to today is a real example where we've got a plant now in commercial operation, which is a greenfield ice cream plant, where we've deployed technology, I would say, across that facility. And we want to just talk through today the process we've gone through to get to where we've got to. And as you said, Jarrod, I think as far as I'm aware, this in the dairy industry is the first implementation where we've got no steam boilers. All our heat source for this process, the process heat source is all from heat pumps. So given it was a greenfield project and there was a real clear directive from the client and very much driven by the marketplace to really drive this as quite a game changer in terms of carbon footprint for a facility. So let's say the driver was definitely there. But we've had to envision this factory along the lines of maximising the maximising to the extent that it's fully with heat pumps. And there's a few versions we went through, but important thing for us was to look at not just directly heat pumps, but the overall energy use of the factory. So there's quite a few phases in the modelling of this plant that we've gone through. Some standard processes that we use at Process Partners, but then we've included on the back of that, I'd say, a level of mass and energy balance beyond what we've done in the past. Again, that requires quite a detailed process of modelling all of the energy across a facility, and then really pushing that to the limits. And just as a bit of a giveaway, so we're talking about a plant that's got roughly a megawatt of heating energy, and we're using in that case a 88-degree hot water system. So we are taking heat, reject heat from a number of sources, but there's HVAC, process cooling, freezers. There's a number of sources we've got that we're using that energy to create hot water. Because it's an ice cream factory, we're fundamentally putting out cold product. So we've got plenty of energy to draw from to create process heat. And I want to just come back to the concept that our whole process follows a hierarchy that we apply across all our designers, engineers. So the first thing we try to do is actually eliminate the energy requirement in the first place. So there's a process that we go through in the design phase through each level where we iterate a design at each level. Quite often in the engineering space, we jump to engineering solutions and try and put equipment in. That's like the first point. Quite often we get involved. So we make a point of trying, eliminate, and substitute. And substitute being, for us, we've substitute the heat source. But there's quite a lot of opportunity in process and food manufacturing where we can actually recover energy at the point of use. So effectively eliminating the need for a external heat source or cooling source. So again, we were pretty thorough around going through each level and looking for opportunities at each level here, rather than just, let's say, engineering to a design. And I'll talk through a little bit more detail the phasing of how we did that. And there's a model process that runs through these different levels. And again, I think for us, what we've been able to demonstrate is we get the greatest financial return by really attacking this early at a very design phase and iterating a number of concepts. So I think for tens of thousands of dollars, you create hundreds of thousands of dollars of operational savings. So, and I think generally, as I've spoken to people across the industry, Australia and overseas, there seems to be, I would say, an opportunity around optimization if we do things well, that there's a 15% gain on the table. As a rough guide, is sort of the order of magnitude of opportunity. So often when people are talking about optimizing, you're talking the few percent. But I think realistically, when we apply this, not only can we have cleaner versions of energy, but our overall energy consumption should be 85% of what it used to be in a plant that we would have built 10 years ago versus today. So there's some real opportunity beyond energy, as you alluded to earlier. Certainly water, wastewater, chemical usage, all of those are savings as an output of this process. Then if I go through those phases, that first phase we go through, level 1, I'll just talk to that. And I've got something. Well, it's jumped ahead here. So what we do at this first level is we actually look at a monthly production level, somewhat how our clients often set up with their financial systems. So we're trying to get the macro model of what a manufacturing footprint is, the key process steps and the key capacities. And we, at this first step, run through and look at what are the product opportunities, put timing into it. So if I'm going to build a greenfield facility, am I building this for 10 years, 20 years? What sort of time frame? What's the future look like? So how do I try and future-proof that, but map it so that I know when I can spend the capital. I don't have to spend all the money up front. So there's a process we do at this level 1 where we find the opportunities to eliminate, I'd say, key waste. When we go through the next level, it's increasing level of engineering detail, time, and cost. So when we have a high level plan mapped and a process map, we then go to this, what we call level 2. Level 2, and I often think as we go through these, they work in different time frames. So level 2, we're actually working at an hourly production base. So we call it the dynamic version. So it's not on a day basis, but it comes back to an hourly basis. So what of all my processes, of what rates, what sizes, how am I cleaning on an hour by hour basis? So this is really aligned to a normal production plan, and all our models are based on actual SKUs. So I'm running which SKUs in which order, hour by hour, through a factory. So that's really giving us a very granular look at energy, water, chemical, everything associated with the process. And then we tune the rates, the sizings, the production. And often with clients, they might come into a CapEx process with a view of what they're going to build. But when we go to this level, quite often we'll change. And in this case, with the ice cream plant, we're able to drop a complete line out for a period of time to say, well, that third line that you're planning, that could happen in 5 or 6 years' time, because our model says we can make it work in the shorter term without a third line. So as an example, this is a high level of detail. Once we've got that detail mapped, we've optimized it. Only then do we ever get into the really detailed engineering of a full mass and energy balance. because again, there's quite a lot of effort and we don't want to iterate mass and energy balances across a lot of manufacturing scenarios. But this is really where we get to I'd say the tin tack level of a full energy balance, but on a time base. So I could have an hour by hour energy balance for a whole week's production, for example, and we might have multiple of those scenarios. And we would run different scenarios at these different levels so that we can really define, in terms of a heat pump application, what are the heating and cooling loads? What does that actually look like on an hour by hour basis? And I've got this thing we call a fourth level where we go, once we've actually designed and built a plant, we actually come back, we end up as a consequence with a number of KPIs for a plant. We put a data measurement system in, and we put a system that we deliver with a factory that you can measure and manage to over an extended period of time. The concept being, I think I'm the good engineer and I can design a great system, but in manufacturing, the world is never constant. So we're always trying to work in a changing environment, and I always need to come back to where I sit against KPIs and have the right metrics in place. So for us, there's a level of sustaining in part of our process. Again, just talking through quickly those different levels. The first thing for us is to make sure we got the building blocks right, because we do a few iterations at this level. It's low cost and quite quick for us to come up with a concept. And generally, when we go back to our clients, we make a lot of our changes here before we ever go into a more detailed engineered solution. Again, for us, the critical thing is phasing. So to put the effort into things where you've already made some key decisions. But as I said earlier, in this case, we're now aligning how a plant will actually operate on an hour by hour basis, based on the actual products that we're making. And then we're really in the tin tacks of the engineering. And again, around driving efficiency in our heat pump solutions, we are trying to look at the balance between all our energy sources, so to make it not a static mass and energy balance, but quite a dynamic one. So as part of our process mapping, we have a full process definition, but in that process definition, we can map out, based on the time of day, what are all the inputs to my process, what are all the outputs, what are my energy, all my heat and cooling demands, so that I can actually map this out for a facility. And basically, you can build a full cost model of a facility. But we would take those demands into a literally hour by hour, day by day, over a full week across each unit of the process and each sort of phase of operation. And again, this is quite a high level of mapping that effectively we can create versions of demand curves. And in this case, facilities, we've done that for looking 10 years ahead. So we can look at, based on different production scenarios, what would my likely energy inputs be? And again, in this case, we've modeled it over an extended period of years. So when we're making investment decisions, we can phase capital expenditure, but ultimately we can look at a plan going forward on time where we can predict with reasonable levels of accuracy. And of course, as I say, in manufacturing, things do change. But when they do, or if new products are introduced, we come back to the model. We do have a pretty detailed version of a factory mapping all our utilities. We can generate these outputs quite quickly when in a changing environment. And the key thing is we've gone through these levels of detail progressively and iterated our design at each level. And look, having been through this and completed a project just recently, we see this as a very good investment up front to get the outcome. And again, we've got an outcome with a factory, which basically all our heating loads have come through a heat pump solution. And again, at this level, when we go to the level of detail, when we're going hourly by hourly, we can really optimize our loads so that, again, this people in operations don't like to say it, but the reality is we design a plant so that there is a constraint on energy. So we design it around being able to work around what those constraints are. And we can factor tariffs in, and we can factor how you optimally run a process to minimize your energy input. And again, we've got, I think, in this case, a well-balanced solution where we've optimized for normal operation. But in the case of the example I'm giving, we've also, and probably not enough consideration to start up, but we sort of tend to design things for normal running. But there is times when plants are down and things are shut up, and how do you get a well-managed, balanced system, starting and stopping when things are out of sync from a time point of view? So in this case, this plant's designed with quite a lot of heat rejection because we don't always have the heating demands, so we'll have to reject heat, and the same thing, we've got to absorb energy. So getting that balance of how it works outside of plan has also been a critical part to make this factory functional and working. Yeah.
Peter, thank you so much. Thank you so much, Peter. You really showed us well in the hour-by-hour analysis. That's what needed. And Llew, I expect some of that looks a bit familiar. Whilst Llew, you were involved in developing the tool, the heat battery tool with Aratherm. I understand Aratherm also does a lot of that detailed modeling as well.
That's right. Yeah.
Yeah. So this is it. This is how to do it properly. And look, these tools, the suite of tools we have just there to get you all started. Peter, thank you so much, and Brendan and Llew, excellent presentations, and great to see these tools up and running, and really hope it helps with the adoption of these decarbonisation technologies.